Okay, so hi, I'm going to be explaining 5a and b. Right now on the board I have my free body diagram, which you can see we have f sine theta, f1 cosine theta, and then we have mass times gravity going in the downward direction, and then we have the applied friction going in the left direction, and then force normal going upwards, of course, to reach equilibrium with gravity. So the question is, calculate the minimum force you must exert to get the block sliding in newtons. So we have the friction force going to the left, and our mass value is 49 kilograms. Our coefficient of static friction is 0.1, and our coefficient of kinetic friction is 0.03. So using Newton's second law, which states force equals mass times acceleration, trying to find force normal, so we're using the sum of the forces equals mass times acceleration, and then we're saying, okay, what is going in one direction? We have one force sine theta, that's one of our forces going in the upward direction, force sine theta plus force normal, which is going in, so these are both going in this direction, so our vertical forces, and then we're going to do our horizontal forces, minus mg equals 0, so equilibrium, and then we have the sum of the forces in the vertical direction is force cosine theta, or in the horizontal direction, minus our friction force equals 0. So I found those by going to, okay, what are my vertical forces? Force normal and force sine theta. What are my horizontal forces? Force of friction, force of cosine theta, and then where is gravity in this situation. And so then I'm multiplying them by each other. So we have force times cosine theta minus mu, which is times mg minus sine theta, and I just found those by plugging in this equation, so I just combined them. And then this tells me force normal equals mass times gravity minus force sine theta, which is equivalent to 49 times 9.8 minus force sine theta equals 0, and then if you reach equilibrium, or equals, and then we plug in our numerical values. So we do mass, which is 49, times gravity, which is 9.8, so we get 480.2 minus 0.4226 F. Just from our coefficient of static friction, which we found from there, and then plug it into this equation, and we get our coefficient of static friction times our mass times gravity value, so this equation I'm plugging in here, that's what I'm doing right now, 0.422 F equals force cosine theta, which is now 25, and this value is 2, what was our force value? We don't know that yet. Oh no, it was 480. 2 equals 0.9063 F. We just found whatever cosine times 25 is, which to solve for that, we just do 480.2, it's 0.1 times that, makes it smaller, divided by 0.9486, and we get F equals 50.622 newtons. So how did I find that, you may ask? Well, I made a free body diagram, and then I asked myself what forces are going in the vertical direction and what forces are going in the horizontal direction. And using Newton's second law, which is force equals mass times acceleration, I was finding the sum of the forces equals 0. So then I just used sine theta, cosine theta, force of friction, all of the values that I had known, my mass value, plugged into an equation that I just showed you how to do, and then I solved for F. So we got 0.9063 by subtracting this, then by finding cosine 25, and then that gave us 50.622 newtons. Just previously forgot to mention why it's sine and cosine. So basically this is sine, so it'll just be that, because it's opposite the right angle, or it's opposite of our hypotenuse, so. And then this is cosine because it's adjacent to the right angle. So if you see, like, if there's a right angle here, it'd be adjacent. Yeah. So I'm just going to also explain 5b. So the question for 5b was, what is the acceleration? So previously, if you remember in 5a, we found the force from force equals mass times acceleration. Now, we are using this formula. F net equals F cosine theta minus force of coefficient of friction times our mass times gravity minus our coefficient. Okay, now let's think this through. So first off, I'm plugging in my force value that I found. So our total sum of the forces from Newton's second law, force equals mass times acceleration. Remember, we found 50.622. We found that because we used this equation and reference our diagram. So basically, you take that value times cosine theta minus the coefficient of kinetic friction because it's moving. The acceleration is moving. The acceleration is no longer stationary. The object is moving. Times our mass times gravity minus our coefficient value times the total force that we just found, the minimum force you must exert on the object. And then this equals, and then you divide it by m, so, right here. So, divided by m, which is, for us, it was 49 kilograms, and then A equals, our force of net, A equals F net divided by m. So, we just found the net force of the forces, and then we divided that by our mass.